Yeah, Bernard. Now we have a longer video, right?
Yes, okay. So we are looking now at the storage layer. So our high-performing, ultra-fast 100 gigabit ports will be configured now. And we're not doing a set switch, right?
Yeah.
We hook them up directly to the system, however, in a redundant way, or two ports for redundancy. And yes, so I'll jump over to your script because I think we don't need to waste time here on that graph.
No, but I want to add something.
Mhm.
You said we don't do a set switch. There are Microsoft designs where they do a set switch and then
Right.
create two separate virtual SMB adapters. I prefer to do it directly on the adapters because
Mhm.
if we add a set switch and then two virtual adapters, we have another layer of software that has
Right.
some advantages but also disadvantages. So I prefer not to get another layer in here. But you can also do that, but be
Mhm.
advised, you then have to do something like bind the virtual adapters to the hardware adapters. Otherwise, the switch decides where the traffic is going. And if it's not working well, both virtual adapters use the same physical adapters. And then you have
Mm.
the same physical adapter, and then you have half the bandwidth. But
So
let's go to the script
yeah,
because it's a long one. Or do you have
yeah.
something to add here?
Yeah, I in some environments, to make it short, you need to make a set switch for the storage traffic because you're lacking the ports. You can't,
Yeah.
you can't avoid it, right? But in our case, there would be no use in doing it, right? Because we can use the direct ports for that.
Yeah,
Anyways,
separate
yep,
adapters.
yep.
So you now this script is a little bit longer.
Hmm.
Part of it you already know. So I ask here again for the last octet. So because we also give our SMB adapters IP addresses. So I have to know what is the IP address for the adapter. Then we have our two SMB subnets, and
Hmm.
I strongly advise to use separate SMB networks, not to put the two adapters in the same SMB network. That's possible. There was a time there was this a best practice from Microsoft, but Microsoft changed it, and there are certain disadvantages to it. But we can talk about that in a separate video where we maybe talk about SMB, Rocky, PFC, and so on. We don't have the time here. Otherwise, we would talk 2 hours. So it's the two networks. We have our subnet masks, and we have to have VLAN IDs because when we use Rocky, we have to use priority flow control.
Hmm.
And priority flow control, we have different priorities. They are from 0 to 7. And the priorities are in the Ethernet packet. And there is a space in the Ethernet packet where you have 3 bits where you can put the priority. 8 possibilities, 3 bits. The 3 bits are part of the VLAN tag. So the host can only signal the switch. This is a packet with priority 3, for example, when there is a VLAN tag. So when we use SMB3 RDMA with Rocky, with the Rocky V2 protocol, we have to have VLAN tags. Even if our adapters, like in our case, are only used for this traffic, there is nothing else there. We have to have trunk mode or tagged switch ports, and we have to deliver the VLAN tag from the host because only the host knows what kind of traffic he puts in the Ethernet packet, and therefore he can set the priority. Yeah? So these are the VLAN tags, and we use the same VLAN tag for both subnets. You can use different. You can
Hmm.
use the same. That doesn't matter. Many network guys prefer to use different VLAN tags if they have different subnets, but that's not a requirement because VLAN tagging is layer 2, IP is layer 3. There is no direct dependency.
And
So
we
then
are
I
not
get
doing any routing between those two networks, right? So
exactly. I don't like for the high performance traffic, I don't like routing because you need high performance routers, and that would be the switches. And
yep.
why should we route the traffic? So here we grab our adapters, we grab
Hmm.
our 25 gigabit adapters, we grab our 100 gigabit adapters, and we grab our adapters. And I do that because the last part of the script is renaming the adapters.
Hmm.
In the moment they have these funny names, get net adapter. Oh, that's not, yeah, you see Ethernet
Hmm.
3, 2, 6, and so on. I
Right.
like to have them names where I know which is the adapter. So therefore we have also the Intel adapters
Hmm.
and the VM adapters included in this script.
Okay.
Then I assign my SMB adapters
Hmm.
to SMB NIC 1 and 2. So in the next step, we enable DCB or we install the DCB feature. We have already done that with our feature installation. You remember maybe Hyper-V failover cluster, BitLocker, and also data center bridging. But it doesn't hurt if we have it again here, but it will not install it because it's already there.
Hmm. Yep.
So then we get the net adapter. So we get all adapters that are RDMA capable, and we turn on the RDMA feature. That's not necessary. Usually in Windows and in Azure Stack HCI, if an adapter is RDMA capable, RDMA is turned on by default, except it's a virtual adapter. Then it's not turned on by default. Yeah, but for hardware adapters,
Hmm.
RDMA is always turned on, and that is a kind of dangerous because if you don't know that you have to configure RDMA, and the adapters are by default RDMA is on, the adapters will do RDMA, but then your network is not configured correctly, and you can run into problems. So I think it would be better if RDMA is turned off by default, but it's not the case. So in my scripts, I have left it here. If I have to run scripts multiple times because something is wrong in the script, it's always hard to continue a half-done configuration with all the variables. So in the beginning of the script, I usually undo everything and then I start fresh. And this is here we remove the net cross traffic classes and the net cross policies. What net cross traffic classes are and net cross policies uh, comes a little bit down in the script. Yeah? So then
Hmm.
we turn off, that's a funny notation. We turn off DCBX. DCBX stands for data center bridging and enhanced capabilities, and we turn them off because we use Mellanox cards here and they are not able to use DCBX, so we have to turn it off. And the willing zero is turn it off. Somehow funny, I think. It's an unusual PowerShell notation. So then we create two net cross policies. And in essence, we say we have SMB direct traffic. So this is SMB traffic that uses RDMA. Yeah?
Hmm.
And RDMA traffic is not TCP/IP traffic. At least in our case, we have Rocky. Rocky is InfiniBand in UDP. Rocky V2 is InfiniBand in UDP. And it can't be lost. So the switches are not allowed to drop the packets. So we must help the switches to identify the packets. And this is a priority. Yeah. So in my environment, I do RDMA for a long time, even longer than Microsoft defined which priority to use for SMB direct traffic. Nowadays, it usually is 3. So priority 3. In my environment, it's still 5, so I have to set 5. What does this? It creates a net cost policy that identifies RDMA traffic. Net direct is RDMA on port 445. This is the SMB3 port also with RDMA, it's the SMB3 port. And if it detects this traffic, it puts the traffic in priority 5. So it marks it, the 3 bits in the VLAN tag, with a 5. And then the switch can recognize, oh, this is 5. I have to be careful with this packet. I'm not allowed to drop it. And we will look into the switch configuration also in the next video. Otherwise, this will be too long. Yeah? So we have our RDMA traffic in priority 5. And then we have another priority. Microsoft added this one for the cluster traffic. Cluster traffic will receive the priority 7. So the switches also can recognize the cluster traffic. So in a modern implementation, you have 3 for RDMA traffic and you have 7 for cluster. There are some vendors like Dell. Dell uses 5 for the cluster traffic and 3 for the RDMA traffic, but that's not really a problem. So the next part, we enable on our host that priority 5 traffic is not allowed to be dropped, because we also get from another host RDMA traffic. And the switch transports our RDMA traffic to the host, and the host should not drop the packets. So we have to tell the host, priority 5, you can't lose. You're not allowed to drop it. Yeah? So this is enable netcore's flow control on priority 5. The other priorities, 0, 1, 2, 3, 4, 6, 7, it is allowed to drop. So the cluster traffic, it can drop. Because the cluster traffic is TCP/IP traffic, and if you drop TCP/IP packets, they will be resent. That's the beauty of TCP. Yeah? So then I turn off all the cross policies on all adapters. So also on the Intel adapters, on all Mellanox adapters, and then I select the adapters where I enable the cross policy. So these are our two 25 gigabit adapters for the VMs, because it is possible that we use RDMA in virtual machines. Yeah, and for that we have to configure the hardware adapter for RDMA and for our two 100 gigabit Mellanox adapters. So, and when we have our priorities, there is also something in the DCB extension of Ethernet. Priority flow control is one part of DCB. DCBX is one part of DCB that we can't use here. And ETS, enhanced transmission selection, is also a part of the DCB Ethernet extension, where we can guarantee bandwidth for different traffic classes. So here we say our traffic class SMB or SMB direct. Here I called it SMB. This is only for us humans that we know what is in there. With the priority 5, this is a PFC priority, guarantee a bandwidth of 50%. Now this is common. Microsoft says 50%, we do that. And then we guarantee our cluster traffic that is in priority 7, 2%. And then we have 48% left. And the 48% goes to the default class. So the effect is we don't really protect our RDMA traffic. We protect the other traffic. We protect our cluster traffic with 2%, and we protect everything else with 48%. So imagine a virtual machine does traffic. It's when it's not RDMA traffic, if it's not cluster traffic, it's maybe Teams traffic. It falls in the default class, and there is a bandwidth guarantee for the VM. So our RDMA traffic, even if it goes over the same network adapters, it's not the case in our design. We have special adapters for that. But if it would use the same adapters, we have still a bandwidth guarantee for our VMs and for our cluster traffic. And the RDMA traffic, if it does RDMA, it will get 50%. and it will get more if there is bandwidth left. But if there is other traffic that uses this bandwidth, it will not get more. So we have a protection of the not so fast classes. Yeah? And this is here. Then I get, say, give me the net adapters with RDMA and show them. It's just to show it. We see it later. And then we do the IP configuration of the SMB2 adapters. So here are two blocks. They are the same for adapter 1 and adapter 2. So what do? We enable this DHCP. Why do I do that? To erase an IP configuration that was on the adapter. You do maybe the same if you configure a network adapter. You have another IP configuration. You can turn on DHCP. Then the configuration is gone. You disable it. Yeah, we do it here. And then we set our IP. So here we set IP v4 with our subnet mask, and here we calculate our address, so the last octet, and in front of it our SMB1 network. And we add the dot between the two variables. So then I do something that I have done for, let's say, roughly 10 years. I'm doing RDMA for 10 years now. I turn off the IPv6 binding on the SMB adapters. So I turn off IPv6. There will be some Microsoft people who say, no, you can't do that. Yeah, but I do it forever now, and it works quite.
I think it's even somewhere in some documentation from Eldon Christensen that you still can do it. I have found it somewhere recently when I was looking for it.
Oh.
So for the storage traffic, it's okay, but usually you would have it on. But yeah.
I do it because when you configure IPv6, you get an APIPA address. Yeah, and I want SMB3 to use the IPv4 addresses and not some random.
So there's a now I recall where I got it from, right? So there is a call, there is a video from Eldon Christensen that he once did, regarding the cluster networking. It is years old now, but it's still worth looking at. And he said once the thing has an IPv6 address, it will be used, right? No matter what you do then with IPv4. If you want to control that kind of thing, right? Especially for that one, I would also turn it off.
Yeah. In my experience, it will not be used, but I want to be sure that it's not usable.
Okay.
So I turn it off. Then we turn off the DNS registration for the adapter. So if you configure IPv4, you can go on advanced, and usually the the DNS registration is on. It will not register normally the adapter in DNS unless you configure the DNS server on the adapter. But then it will register also this IP address in DNS, and I don't want that. Yeah? Then this one is we set our VLAN ID on the adapter because we have to use VLAN IDs so that our priorities, PFC priorities can be set in the VLAN adapter part. And this one is something very old one. We turn off net BIOS on the adapter. It's another if you do it graphically on a Windows server with a GUI, you can also go to NetBIOS, and usually it's on. I disable it, and this is you do it over VMI. It's a little bit complex in PowerShell, but it's doable. So I turn it off. So and then here we have some specialities we can talk about. I get all the time the question, do you use jumbo frames with RDMA? And usually I do it not. But in this example, I set jumbo frames to 9014. Be aware, RDMA traffic has a special configuration for the jumbo packets, and it will not use 9K. The biggest packet RDMA can use is 4K. and usually the adapter will exchange the information, and usually they will do 1K packets unless you increase the size. But when I have installations at customers with 1K and you get nearly line speed, why should you bother
Mm.
about jumbo frames to get maybe 0.5% or 1% more? Yeah? I have seen installations where the jumbo frames were not correct and you get some problems with that. So usually I
Mm.
don't configure jumbo frames, but to be fair and honest, as most of the OEMs have jumbo frames configured in their configuration examples, so you can do it.
Mhm.
And the last one is also a specialty for Mellanox cards. We turn off or we set the DCBX mode in the driver to host is in charge. Usually there is firmware is in charge. So that's very special to Mellanox. You can forget it if you don't have Mellanox adapters. So then we have this again for the second adapter.
Mhm.
And here's the part where we rename these adapters to some names I can recognize. So Mellanox 25, NIC 1, and so on, and Intel. So this is the whole script. And now let's cross our fingers and I will run it.
Mhm.
Create SMB. So again, it will ask us for the correct IP address, and we are on host 1, so that would be 51. And it will collect some data, what is installed.
Mhm. Yes, as you did the data center bridging, right? So no change needed here because it was installed
Exactly.
before, right? Okay. Yeah, that's quite a lot, right? And sometimes the documentation for what you have all there is not so easy to find on our websites. There are other vendors that sell HCI configurations, and they have deployment guides for that. So, take the big ones and look the internet up for deployment guides on HCI, and you should be able to find some. And
Yeah. So let's give our viewers a bit more of a hint. I
mm,
know at least two vendors who have a good installation documentation. This is Dell and is Lenovo, and
mm,
maybe there are others, but of those two, I know they have a good
yep.
documentation about the installation of Azure Stack HCI. Of course, it's tailored for their systems, but you will find all these commands in a PowerShell script. I'm not agreeing with everything what is there, but most of the stuff is very good. Yeah?
Mm,
So you now see we create our classes, we will configure IP, and maybe this is a good time to also look at a switch. So let me see if because before we wait, I will start a web browser on another screen.
and that would be the Mellanox switches, right? Because we
Exactly.
have connected them to it. Okay.
But first I don't have to do, I, I should type the correct addresses.
Yeah, sometimes it's hard for, depending a little bit on the switches that you have, to find always the right configuration. Most of them, I mean, if you would would search for the switch configuration, Cisco does have a lot of configuration command lines. Sometimes they are similar, sometimes they are
Yeah,
different, right? So it's depending on the model or of the make of the switch window, right? If you have
yeah.
a GUI tool or if you are using the command line for doing this. So yeah, it's
The hardest part is really the configuration of the
right.
switches. The switches have to support, if you do Rocky. For
Yeah.
IWAP, it's another story, but for Rocky, they
Yes.
have to support PFC, so priority flow control. And that's not enough that a switch supports PFC. You also have to know how to configure it. So you have to know
Mm.
the command commands, the CLI commands from the switch. And this really is the hard part.
Yeah.
With Mellanox switches, at least with this Mellanox OS, there are two
Mm-hmm.
kinds of OSs for Mellanox. That's the original Mellanox OS, and then there's Cumulus.
Mm-hmm.
And newer switches tend to go to the Cumulus OS. But
Mm-hmm.
here in the old operating system, and you see here, Mellanox was acquired by NVIDIA.
Mm-hmm.
So now they are NVIDIA switches. Yeah? So what have we to do? First,
Mm-hmm.
in Ethernet Manage, here in the GUI, we find a priority flow control.
Okay.
And we have to turn it on. So by default, priority flow control is not turned on because it's
Mm-hmm.
extra work the switch has to do.
Mm-hmm.
And if we don't need it, why waste CPU cycles for it?
Mm-hmm.
So I have to turn it on and I have to tell the switch which priority,
Mm-hmm.
0 to 7, is lossless. And in my environment, it's 5. If I would install this fresh from scratch, it would be 3. But I have everything on 5 and I don't want to change it. So here we have the 5. Then we have to create VLAN tags, yeah, because we have to allow our switches to use VLAN tags. And you see
Right.
here, here's the 812. We have a PowerCourse SMB
Mm-hmm.
VLAN tag.
Mm-hmm.
I created it. And then the last part, on the ports where we expect PFC, so priority flow control, for example, the connection between the switches,
Mm-hmm.
or let's say port 9 here should be one of our, yeah, you see
Right.
here, it's
Mm-hmm.
the SMB1 port. This is another one. These are also other ones. And here we have to go and enable priority flow control. Normally it's on flow control mode none, and we
Mm-hmm.
have to enable it for PFC.
Right.
And that is all we have to do. We have to enable lossless PFC, and we define lossless priorities. We have to define VLAN tags, and we have to allow, of course, the VLAN tag on this port.
Mm-hmm.
And then we have to enable PFC here. And that's
Mm-hmm.
all you have to do in a Mellanox switch. If you want to do some ETS,
Mm-hmm.
so an enhanced transmission, now I'm missing the word, selection. So
Mm-hmm.
you have to go to the CLI and also configure something there. But for PFC, the most important part, that's all doable in the GUI. So our
Okay.
host is done. If we get the adapters again, you see now we have nice names here, and we have also our priorities, get net quos policy, not nerd quos, it's net quos policy. We see here we have our 7 and we have our 5, and there is another 5 that's from a former configuration. This we didn't do in the script. It was there before. So it seems I tested this script before.
Yeah.
Forget this one. It's for TCP, SMB over TCP. You don't have to do that. There are some vendors who do it, some don't. Yeah. So we have that, and then there is the netquos. What was the other one? We just look here. Netquos flow control, of course. Flow control. We see our 8 priorities, and the host knows priority 5 is flow control enabled, so he has to handle the packets lossless. Yeah?
Mm-hmm.
And if we look at the net adapter, that's also something I typed wrong. Here we see all the adapters that are RDMA capable.
Mm-hmm.
Our 4 NIC Mellanox NIC ports. It's enabled and it's operational. And you
Mm-hmm.
see here our management adapter is also RDMA enabled, but it can't do it because the Intel adapters that are on the management switch can't do RDMA. So it will not do RDMA. We could disable it, of course, but the 1 gigabit Intel E i350 adapters are not RDMA capable. No? Okay, I think that's all we have for here. It was a long video, and see you on the next one, right?
And what do we do on the next one? Obviously, that's a lot of stuff that happened. In order to make sure that this is correct, I think we do some testing around this
Yeah,
to
we
really
test
make
the
sure that
RDMA.
this is working. Okay. Yeah. See you in the next video.